problems on electrical circuit. Mainly we have the problems on LCR circuit. I am explaining the LCR circuit here. Consider the discharge of a consider C through an induction L and resistance R. These are the notations, induction L and resistance R. Since voltage drop across L, C and R respectively. L is nothing but across the induction and capacitor and resistance. Then by using these letters, we are framing one differential equation, that is nothing but L d square q by dt square, means voltage drop across the induction L, that is the voltage drop, and through capacitor q by C, and another one R dq by dt. According to Kirchhoff's law, we will frame the differential equation, we will add it according to that Kirchhoff's law, means we have to add all those voltage drops summation. Then L d square q by dt square plus R dq by dt plus q by C equal to 0. Means, observe this one, this is the differential equation, second and higher order differential equation. You can solve this differential equation by general method, means complementary function plus particular integral. Now, first problem on this method, a condenser of capacity C discharged through an induction L and resistance R in series. There are different types of series or parallel series like that according to that problem. This is physics problem. And the charge Q at time t satisfies the equation directly. In most of the problem they will give the from the Kirchhoff's law they will give this differential equation. In this question they have given the direct question also, L d square q by dt square plus R dq by dt plus q by C equal to 0. Means these are nothing but voltage drops along LCR circuit. Now given L equal to 0.25 units, this is henries, and resistance capital R equal to 250 ohms and C equal to 2 into 10 to the power of minus 6 farads. And when t equal to 0, time t equal to 0, charge Q is 0.0002 coulombs. Then the current dq by dt is 0. Obtain the values of Q in terms of t. First of all, you take this differential equation, you calculate the solution for this differential equation in terms of, here Q is dependent variable with respect to time. If time changes, then Q also changes. Then that's why dq by dt, t is independent variable, Q is nothing but dependent variable. In that manner you solve the differential equation. Now the same concept again, given differential equation is L d square q by dt square plus R dq by dt plus q by C equal to 0. Means we don't want any terms, coefficient terms. That's why I will convert into in the standard forms, d square q by dt square plus R by L into dq by dt plus q by LC equal to 0. This implies you substitute all the values, R equal to 250 ohms and L equal to 0.25 and C is nothing but 0.25 into 10 to the power of minus 6. Now you substitute all these values, then d square q by dt square plus 250 by 0.25 plus q by 0.25 into 10 to the power of minus 6 equal to 0. Now RHS side q of t value is 0, means no need to calculate the particular integral. Therefore complementary function is the general solution for this problem. Means that is the general solution, means RHS side if q of x equal to 0, means no need to calculate the particular integral, no operations for all these things. D square plus this 250 by 0.25 means this is 1000 D. Actually 1000 D means 25 on the 25 tens, then according to that decimal calculation 1000 D, you can use scientific calculator also. 2 into 10 to the power of minus 6, this is nothing but on simplification 2 into 10 to the power of minus 6 into q equal to 0. I have taken q common, this is dq by dt. Now auxiliary equation for this one, auxiliary equation f of m equal to m square plus 1000 m plus 2 into 10 to the power of minus 6 equal to 0. Means we are calculating the complementary function, m equal to minus 1000 plus or minus under root 10 to the power of minus 6 minus 8 into 10 to the power of minus 6 by 2, means according to formula minus b plus or minus square root of b square minus 4ac by 2a. Otherwise you can use without using that formula, scientific calculator also we will calculate the answer. Minus 1000 plus or minus 1000 by under root 7 under root 7 I by 2. Therefore m equal to, I got the roots, minus 500 plus or minus 1323 I. Then these roots are complex numbers. Means complex numbers means a plus or minus ib form. Then recall the formula y equal to, if m equal to a plus or minus ib, the formula is y equal to e power ax into c1 cos bx plus c2 sin bx. Then according to that one, yc, the independent variable is t is there, and dependent variable q. That's why I am writing here LHS side q equal to e power minus 500t e power ax. Therefore means e power, independent variable is t, e power minus 500t into c1 cos 1323t plus c2 sin 1323t. Now observe this one, when t equal to 0, q equal to 0.02, means you substitute these values. Now this is the actually final solution. Then they have given some conditions, those are nothing but initial conditions they have given. According to those initial conditions, you calculate the arbitrary constants. Here arbitrary constants are c1 and c2. Then using those conditions, initial conditions, you should calculate c1 and c2. Now first initial condition, time t is 0 and q equal to 0.002. Therefore this implies, when you are substituting all those things, then on simplification by using scientific calculator, I got c equal to 0.002, q equal to 0.02, right, c1. And second initial condition, t equal to 0 and dq by dt equal to 0. First you do the differentiation for q. Then dq by dt equal to minus 500 into e power minus 500t plus c1 cos 1323t plus c2 sin 1323t. uv formula, first exponential function I did the differentiation of the exponential term, that second term is as it is constant. Now first term is constant plus e power minus 500t, then this can be written as c1 cos, means 1323 into minus c1 sin 1323t plus c2 cos 1323t. Means that finally 1323 constant anyhow in this. If t equal to 0, c2 equal to 0.0008. Therefore the final solution q value, the discharge q value, e power minus 500t 0.002 into c1 cos 1323t plus 0.008 sin 1323t. This is the final answer of the given LCR circuit.